now we're recording. Okay. So if you remember, when we're solving equations, the biggest roadblock we have are parentheses. You cannot solve for anything if there's parentheses in your equation until you get those parentheses away. When you have a number and then parentheses, what must you do with that number? In the back. Distribute, you got it. So we're going to distribute in that 3. So we are 3y minus 6 plus 3. And now I'm going to distribute in that 2. 2 times 6 is 12. 2 times a negative y is a negative 2y. All right, once we get rid of the parentheses, our main goal is to get everything with a variable on one side and everything that does not have a variable on the other side. That's ultimately your goal. Get everything with a variable on one side, everything that doesn't have a variable on the other side. Now, I'm looking on my left side. Before I start moving things over, does anybody see what I can do to condense that left side a little bit? Any like terms there? Negative 6 and 3. How come I can't do negative 6, 3, and 12? Why can't I put those all together and add? Say, okay, well, negative 6 plus 3 is a negative 3, and negative 3 plus 12 is a positive 9.
It's actually a negative 12.
Well, if we bring it to the other side. But right now, are these all on the same side? No, that 12's on the other side of the equal sign. That cannot be added if they're on different sides of the equal sign. So that 12 is not included. So now we're going to have 3y minus 3 is equal to 12 minus 2y. So now that we've condensed that left side a little bit, I want to move some things over. So I'm going to bring that 2y over to the 3y. So now we're going to have plus 2y, and we will have 5y minus 3 is equal to 12. Now it's down to our normal two-step equation. What should I do now? You got it. We're just going to add that 3 on both sides. So now we have 5y equals 15. Last step, divide by 5, and y is equal to 3. Solving equations should be the topic you're most proficient on. All right, so you guys all try number 2 on your own. You guys all try number 2. All right, who has an answer for me for number 2? Just looking for the answer right now. In the back, what's your name? Ethan?
I got 43.
X equals 43. Did anybody get a different answer? How many people got x equals 43? Good. Who wants to see me do this? That is the correct answer. Don't be shy. We're good? Okay. All right, so now let's look what happens when you have a fraction. So here, I'm actually going to do number 4. I'm going to do number 4 before 3. So here we're going to have 3 over 4x minus 7 over 12 equals 1. Biggest mistake. Biggest mistake whenever you're dealing with an equation with fractions is creating a common denominator. You do not want to create a common denominator. You don't want to deal with the fraction at all, right? So the best practice is to eliminate the denominator. How do we eliminate the denominator? Well, you look at the 2 or multiple, if there was like 4 denominators, you'd look at all of them. Look at all the denominators. And then you'd say, okay, well, if I were to create a common denominator, between 4 and 12, what would that common denominator be? 12. If we were to create a common denominator for 4 and 12, our common denominator would be 12. But we're not going to create a common denominator. What you do to eliminate the denominator is you multiply every term by that common denominator. So what I'm going to do is I'm going to do 12 times 3 over 4x minus 12 times 7 over 12 equals 12 times 1. Everything gets multiplied by 12. Every term on both sides to keep the equation balanced. As long as everything gets multiplied, you're not really changing the value of the problem. Now, at this point, when you're multiplying, you could just multiply across. You could say, well, 12 times 3 is 36, but then 36 divided by 4, isn't that 9? Right? That's not the best way to do this. You can do it that way, though. The best way to do this is anytime you're multiplying a fraction with another fraction or a fraction with a whole number, you can cross-simplify. Do you guys all remember that? The cross-simplification when you're multiplying? Can you cross-simplify if you're adding? No, you could only cross-simplify if you're multiplying. So I can say, well, 4 goes into 12 3 times. And then 12 goes into 12 1 time. And then obviously there's no cross-simplification here. This is just 2 whole numbers being multiplied together. And now we multiply. So I have 3 times 3x is 9x. Negative 1 times 7 is a negative 7. And 12 times 1 is 12. So now I went from what looked like a pretty complicated problem with fractions to a very simplistic 2-step equation. We're going to add 7 on both sides. So we're going to now have 9x is equal to 19. Divide by 9 on both sides. And we have x is equal to 19 over 9. In the middle school, they love to have you make mixed numbers. We don't love mixed numbers in the high school. We love improper fractions in the high school. So what you would do is you leave your answer improper and simplify it if possible. Is there any way to reduce 19 and 9? No, so then you would just leave it just like this. The only time we make it into a mixed number or a decimal is if it then makes it easier for us. So like if I were plotting points and the coordinate ended up being a decimal, in that scenario, it's easier to make it a decimal than an improper fraction, right? Like 5 over 2 is a lot easier to plot if it's 2.5 versus 5 over 2. But in the sake of like just algebraically, we always leave things improper. All right, so you guys go back now and do what number was it? 3. Oh, just so you know, that's a negative 3 over 4y plus 2 equals 14. Anytime there's a negative, I always just assign that negative to the numerator. There's a fraction. I always assign it to the numerator. Who has an answer for me? Anybody get anything different? How many people got negative 16? What everybody else got? Did we not finish yet? No? All right, so negative 16 is the right answer. Should I do this? Anybody want to see me do it? Yeah, let's do it. All right, so we have negative 3 over 4y plus 2 equals 14. There were two different ways to do this. Since this wasn't a fraction, you could have subtracted that over. How many people did that first? Subtracted the 2 over. That's okay. The other way to do this is sort of following what I had done before and saying, okay, well, there's a denominator of 4. Let's just go through and eliminate that denominator. And if you did, how many people did it that way? Okay, so I'll do it that way. So there's no other denominator. So there's no choosing a common denominator since there's only one denominator. So I'm going to multiply everything by 4. So this is 4 times negative 3 over 4y plus 4 times 2 equals 4 times 14. Every single thing needed to get multiplied by that 4, even the 2, even the 14. That's how it stays balanced. So in the first one, because we're multiplying a fraction, we can cross simplify. So those 4's cancel. So now you have negative 3y, and you have 4 times 2 is 8. And then you're going to have 4 times 14 is 56. Yeah. So now we subtract that 8. And we're going to have a negative 3y equals a positive 48. Divide by negative 3. And we get y equals negative 16. All right, next part, factoring. All right, if you all remember, you guys should have spent a ridiculous amount of time in Algebra 1 on factoring. When you're factoring, what's happening is we're working backwards. I've given you the product, the answer of two things that have been multiplied together. I'm giving you the answer to it. And I'm saying, go backwards, work backwards with me now. Tell me what two things multiplied to give me this trinomial, to give me this expression. So we're working backwards. And if you guys remember, most of the time you ended up with like a double set of parentheses when you were factoring. Okay, before you start factoring, there's a couple of things you want to make sure of. You want to make sure that your expression is in descending order, meaning your biggest exponent down to a number that doesn't have a variable at all. So x squared, x, and then your constant. That's exactly what we want. Okay, second thing, whenever you're factoring, you're always looking for a GCF first. Your factoring could end up being wrong if you don't pull out that GCF first. So the way you choose a GCF is you look at each term and see if there's anything common amongst them. So we have x squared, 5x, and 24. Some people might say, oh, we can pull out an x. There, we can't pull out an x. Why not? Because the 24 does not have an x in it. So x squared, 5x, 24, is there even a GCF there? No, but you always ask. That's always what you look for first. Since there is no GCF, we're going to go straight into factoring. And the way you go straight into factoring is you set up your double set of parentheses. I know two things are going to get multiplied together. And the way we do this is you ask yourself, well, what times what will give us this first term? So what times what gives us x squared? X times x. So now here's the part that's a little bit thought-provoking. You need two numbers that multiply to the last number, but those same two numbers have to add to the middle number. So can somebody, let me move this away, can somebody tell me what two numbers multiply to a negative 24 but will add to a negative 5? You got it. So if we do a negative 8 times 3, do we agree negative 8 times 3 is a negative 24? But then we check the middle term. You always have to check the middle term. Negative 8 plus 3. Is negative 8 plus 3 a negative 5? Then we're good. Then the two numbers that you guessed to make it fit, make that work, you're going to put into your parentheses. X minus 8 and an x plus 3. Does anybody remember how to check to make sure you factored correctly? Exactly. You're going to FOIL back out, and what should you end up with? Your original problem. So let's just do that real quick. So we are x minus 8 and an x plus 3. X times x is x squared. X times 3 is a 3x. Then we're going to have negative 8 times x is a negative 8x, and negative 8 times 3 is a negative 24. We're going to combine our like terms, 3x and negative 8x. So we have x squared minus 5x minus 24. Is that what we had originally started with? Yes. That means we have factored it correctly. What happens if you check it and you didn't get your original problem? It means you did something wrong in your factoring, or you did something wrong in your check, one of those. All right, you all try number 6.
To do the check too, or just...
No, you don't have to check. I just showed you the check in case you want to. All right, who has the factored form of this? PJ, right?
Yeah, x plus 6 and x plus 2.
You got it, an x plus 6 and an x plus 2. How many people got that? Perfect. Anybody want to see me do this? Okay. In number 7, before we start making our double set of parentheses, what do I really hope you recognize here in number 7? I want to say Ethan, but, oh, it is, okay.
We have to factor out the 2.
Excellent. 2x squared plus 2x minus 24, there is absolutely a GCF of 2. So what we want to do is we need to factor out that 2. We pull a 2 in the front, and then you really just go back and divide everything by that GCF. And when you divide everything by that GCF, you're left with x squared plus x minus 12. What number is really in front of that x, that second term, even though there's no number written? 1, you got it. There's really a 1 there. So now, when you come to factor, the 2 needs to be in the front. And then you set up your double set of parentheses. And we're going to have our x and an our x. But now we are looking for 2 numbers that multiply to negative 12, but add to a positive 1. Does anybody know what our numbers are?
James.
I know, I want to call you Luke. What'd you say?
4 and negative 3.
4 and negative 3. So we're 4 and negative 3, and then that's a negative 12. Then we check. You got to check the signs. Positive 4 plus a negative 3. Isn't that a positive 1? So we are good. So we are x plus 4, x minus 3. If the 2 is not in front, it is not correct. If the 2 is not in front, it is not correct. Can somebody tell me, how does number 8 look different from the other 3 problems we did? What's your name? Casey. There's only 2 terms, and I love that you use the word terms. All right, excellent. There's only 2 terms. Number 5, 1, 2, 3 terms. Number 6, 1, 2, 3 terms. Number 7, 1, 2, 3 terms. Number 8, 1, 2. Terms are split between plus or minus signs. That's how you know when something's a term. Right? There's only 2 terms here. Whenever you only have 2 terms, there's only one kind of factoring you can do. You always still look for GCF no matter what. GCF first no matter what. But once you look and there's no GCF and you only have 2 terms, there is only one kind of factoring. Does anybody know what that only kind of factoring this could possibly be?
Isn't it called like a perfect
So you're right, you got part of it. Something squares.
difference of squares?
Good, the difference of 2 squares. I call it a dot. Has anybody ever heard the word dots before? Okay, so I call it dots. It's the difference of 2 squares. What does that mean? It's actually the easiest way to factor is a dot. So first thing you have to check for, is it a difference, meaning a minus? Is it a minus? Yes. On either side of the minus, are they both perfect squares, meaning something times itself gives us that number? Yeah, x squared is a perfect square, x times x is x squared. 49 is a perfect square because 7 times 7 is 49. So now what we do is we set up our double parenthesis, you make your x and your x, and then you do 1 plus and 1 minus. The reason you have to do 1 plus and 1 minus is because a positive times a negative is a negative. That's how we get our minus in the middle. And then you do basically that last number, that 49, what times itself gives us 49? 7 and 7. Hand up, no? We're good? 7, 7, that all comes from the 49. Now, when you check this, the middle term cancels out when you FOIL back. You don't have to write this down. I'm just going to show you the check. So it would be x squared minus 7x plus 7x minus 49. What happens when you have a negative 7x and a positive 7x? Cancels right out. That's how we get the x squared minus 49. All right, number 9. Some of you might look at this and be like, dots. I'm going to say yes, but not yet. Why? Why am I saying yes, but not yet?
You have to take out the
Exactly, because there's a GCF there. So now when we go ahead and we pull out this GCF of 4, we're going to have x squared minus 25. Now we look inside our parentheses. Is x squared minus 25 a dots? Yes. So now we have that 4 in the front, and we are in x plus 5 and in x minus 5. All right, number 10, in my mind, I hate reviewing, because if there were 10 different teachers, every single one of those 10 teachers taught this a different way. And I don't know who you had for Algebra 1 or how that person taught it. I really don't know. So how is number 10 different from all the other ones we've done? PJ?
You can't get a GCF and there's a 2 from the
Yeah, there's 2, 21, 10, no GCF there. And now that there's a 2 in front of the x squared, this is called factoring with a leading coefficient. Some of the teachers, I think Mr. McCarthy does like their earmuffs. Some teachers do some X thing where you put a number here and a number here or there. I don't know this X thing. I don't know. I don't know how your teacher taught it. So what I'm going to review is sort of just the very basic guess and check. Right? So what do I mean when I say very basic guess and check universal? However your teacher taught it to you, that's how you should do it, because you probably spent a month doing it the way your teacher taught it to you. But ultimately, what's going on in here is I've given you the product. I need to know what multiplies that. So we set up a double set of parentheses. And you look at the first term. You say, okay, well, what 2 things multiply to 2x squared? There's not many things, right? Because 2 is prime. So your only options are 2x and then x. No other options. Nothing else multiplies to 2x squared. Now what I'm going to do is I'm going to look at the 2 signs I'm dealing with. We're multiplying to a positive, but then we're adding to a negative. Multiplying to a positive and adding to the negative. What do my signs have to be if I'm multiplying to a positive, but then you're adding to a negative? The only way that works if both numbers are what? Negative, if both numbers are negative. Because I know I need both numbers to be negative, I'm going to put 2 minus signs in here. And this is where the guess and check comes in. So now I'm looking for factors of positive 10. So we can do negative 10 and 1, negative 1, right? And we could do negative 5 and negative 2. Do we agree? Those are the factors. So now we have a whole bunch of different things. We can put these numbers in and see what works out. Now I know when I FOIL back, I'm going to have to add to a negative 21. And now this is where sort of you have to think a little bit strategically. What's going on here? I'm multiplying the 2x with whatever number's over here. And I am multiplying this x with whatever number's over here. Do we agree? Like when you FOIL back out? All right, so basically in this FOIL back out way, I need to somehow get a negative 21. So I'm looking here. Even if I put the 5 here, 2 times 5 is 10. Right? Is 10 close enough to 21? It's not really going to get me close. All right, so then I'm going to use the 10. But let's put the 10 in the wrong spot. Let's say I put the 10 here. So if I put the 10 there, that means I'm putting the 1 here. So if I check this, it's going to be 2x times 1 is 2x. Negative 10 times x is a negative 10x. You add those. 2x, oh, sorry, negative 2x. Negative 2x minus 10x, that's a negative 12x. Is that what I want? No, I need a negative 21. So what do I have to do? I have to switch those numbers. So I'm going to now put the 10 here and the 1 here, and now I'm going to check that. So I'm going to do 2x times a negative 10. Isn't that negative 20x? Got me pretty close to that 21. Now I'm going to do negative 1 times x is a negative 1x. What's negative 20x minus 1x? Negative 21x. That's what we wanted. So my factored form is going to be 2x minus 1 and x minus 10. Okay, I want you guys to try number 11. Who wants another minute to finish up? Okay. All right, let's go over this. So what should you have done? We should have noticed there's no GCF here, so we're going to do 2x and x. Let me move this down. Now, I'm multiplying to a negative, but then I also have to add to a negative, which tells me my signs have to be different. I need one positive and I need one negative, which complicates things a little bit more. And then our last number that we're trying to multiply to is the negative 15. So we have some options here. We have 1 times 15 and we have 3 times 5. But within those scenarios, one of them has to be negative, right? So the 1 could be negative or the 15 could be negative. The 3 can be negative or the 5 can be negative. So it's sort of just a little guess and check type of deal. Now, do we agree that we need to add to the negative 7? Which means our bigger like multiple things should be the -1. So remember, the 2x gets multiplied with whatever number is here, and the x gets multiplied with whatever number is here. We need to get to 7. Do you think in any of these scenarios the 15 and the 1 will work for us to get us to 7? 15 and 1 will never work to get us to 7. That means we have to play with the 3 and the 5. Let's do it wrong. Right, let's do it wrong. Let's say I put the 5 here and the 3 here. And then I say, okay, well, 2x times 3 is 6x, and 5 times x is 5x. Notice I didn't put any signs in. Is there any combination of 6x and 5x, positives, negatives, that will ever get me to 7? No. So it's not that the numbers are wrong, it's that the locations are wrong. So now let's try it again. Let's put the 3 here and the 5 here and see what we get. All right, what do we have now? So now I have a 2x times 5 is a 10x. A 3 times x is a 3x. Is there a combination of 10x and 3x that could get me to that -7? Yes. Which one should be negative? The 10x or the 3x? The 10x should be negative. If the 10x should be negative, where should I put the negative? Should I put it with the 2x or should I put it with the x for me to get a -10x? We need to put it with the x and 5. So that way 2x times -5 is a -10x, and then the positive goes with the 3. And then positive 3 times x is a positive 3x. And that gets us to the -7. So our factored format is 2x plus 3 and an x minus 5. All right, you guys try number 12. What should you do before you factor for number 12? Good. Check for your GCF, and there absolutely is a GCF there. It's not 6, but there is a GCF. And we're going to end there, and we will finish this lesson or this algebra review up tomorrow. So we'll end there and finish this up tomorrow. It looks like the bell is going to ring in 2 minutes. So you guys can finish up, but just remind me to go over number 12 tomorrow. Just remind me to go over